All right, now that we have learned how to do the calculations, given the 3-time estimates of activities, of activity durations, let me present to you a solution framework that you're going to use from now onwards when you are asked to find the following. You know that all the activities have probabilistic durations, which means that you are not able to tell that the project will take a specific time, right? We cannot say that it will take 20 weeks, 23 weeks, like in the case of the deterministic case. But we will be making a statement like that. The probability that the project will be within, let's say, 25 weeks is 73% or 65% or 97%. So we will be making a probability statement about the project completion time. All right. So to do that, this is the solution framework. We are given the activity 3-time estimates. And as we learned from that, we can get then the activity expected duration using what formula? Here we go. I'm just reminding you of the formulas that we have seen. Then also we can find the activity duration variance. Remember, the activity duration is a variable. So you can call it X. It has an expected value. It has a variance. All right. Then from the activity variance, we can, this is how we find it. And then from the activity variances, we can find the path duration variance. So here, remember, from now on, we will be having, this is how we start. For every activity, we have 3-time estimate, which means an activity A, for example, its duration, we can call it a variable X. Okay. Then we have activity B, a variable Y, activity C, variable Z. Then from these, we are deriving a new variable, which is the path duration. It's another variable. That's, for example, W, all right, which has a variance, okay, because it's a variable. And then we just sum up the variances of the activities in that path. Then from the activity expected duration, we can find the path expected duration. How? By summing up the expected durations of all the activities belonging to that path. And then from the path duration variance, okay, I find the path duration standard deviation. I need that. I'm going to show you very soon why I need that. Now, these two pieces of information for my variable W, which is my path duration, so its expected value and its standard deviation, I can answer a question like that. What is the probability that the path duration will be within a certain time? Okay. Doing this will allow me to do the following probability statement about the project completion time. How? In fact, here we have two approaches. In our textbook by Stevenson, it says that the probability of a project completion time is the product of the probabilities of all the path completion time. Yeah, for example, if we have a project with 4 paths, path 1, 2, 3, 4, and then the question is find the probability that the project, what the probability that project will be completed within, let's say, 13 weeks. So we find the probability of path 1 finishing within 13 weeks, and path 2, and path 3, and path 4, and we multiply these probabilities. However, this is very time consuming for us, so we're not going to do it, even though this is the right way. But there is another approach, more simplistic, which says that in order to find the probability of the project completion time, we simply find the probability of the critical path being completed within that time, and that's it. This will be equal, okay, it will be equal to the probability of the project completion time. Okay, so we're going to adopt this simplistic form. Okay, in the next example, I'm going to illustrate how we use this solution method, and I'm going to finally tell you why do I need the expected value of the path duration and its standard deviation to answer the ultimate question about the project completion time. All right, so get ready. All right, so according to the solution framework that I showed you in the previous slide, this is how we're going to proceed. The question would be find the probability of the project finishing within a certain time. Okay, let's call it a target time, desired time, whatever. So just one more comment before we proceed, that in order for this one more step to be able to do it, we have to make the following assumption, that the path duration, all right, remember it's a variable, and it follows a normal distribution. Only then I will be able to use my magic z value, remember it, where z is equal to x minus mu over sigma. Remember this relationship between the values of z and the values of x, where x is a normal distribution with a mean of mu and standard deviation of sigma. So for every value of x, I can find its corresponding value z. So when the question is find the probability of the project finishing within a specified duration, so this is what I do. I find then z to be equal to that duration minus the expected path duration. You see, this is the first piece of information that I was emphasizing that we need, divided by the standard deviation of the path duration. This is why I was repeating again and again that I need these two pieces of information so that I can find for any value of x or w, whatever you call that variable, which represent now the project completion time, okay, I can find a variable, the corresponding value of z. Why z is important? Because z tells me how many standard deviation, okay, of the path duration we are beyond or below the expected path duration, or the average path duration. Okay, so then it will be, then I can answer the question about the probability of finishing the project within a certain time. All right, once z is known, I look at the table, so I hope that you are already familiar how to use the z table. Anyway, in the next examples, I'm going to show you again, I'm going to remind you how to read the z table. Okay, but I'm going to do that only for 2 questions, and then you have to do it on your own. All right, and that's it. From the z, you go to the table, and you will be able to read the probability that we are looking for, okay, of the project being able to be completed within a specified duration, which we used here to find z. All right. Right before we proceed, just quick notes about the assumptions. So we're assuming that the completion time of the project is a variable that has a normal distribution, and something that we did not mention before, that the durations of the activities within the path, each one is a variable, remember, but it's very important that we consider these as statistically independent. It's very important. You don't need to worry about it. Just take my word for that we have to make this assumption. All right, and we're adopting, as we said before, the simplistic approach, which is the probability that the project completion within a certain time will be equal to the probability of the critical path completion within that same time. Okay, but don't remember that this is not the exact approach. Why is this? Because sometimes we have a path which is shorter than the critical path, however, it has a much higher variability that it will pose a higher risk on the project completion time than the risk that is posed by the critical path. This is exactly why it's better to always use the other approach, which is the longer approach, where you have to find the probability of every path in the project finishing within the desired or the specified duration, and then multiply all their probabilities. So you consider all these risks, okay? But for us, we are again taking the simplistic form.